Hey everybody, a couple more examples for you, a couple weird scenarios for you. So you're solving a system of equation with three variables, and this problem's going to start normal, but you're going to see very quickly that this kind of unravels, and I'll explain what this all means. And then more broadly speaking, like what the heck is going on when you're solving one of these. So let's go ahead and try this out. We'll start by, let's try to get rid of the x's. So I'm going to label these 1, 2, and 3. I'm going to, let's see here, let's pick 1 and 2 together and we'll get rid of the x's. Now to get rid of the x's, to get these x's to be opposite, I'm going to have to multiply the first equation by 3. So I'm going to write that down. I'm going to multiply the first equation by 3. And that is going to get me 3x minus 6y plus 3z equals 9. And I'm going to just drop down the second equation. So the second equation is just negative 3x plus 6y minus 3z equals negative 9. All right, so what you're going to notice is that not only are my x's opposite, but my y's are opposite, my z's are opposite, heck, the other number is opposite. So if I added these together, this would, well, be 0, 0, 0. So pretty much the whole entire left side just becomes a big whopping 0. On the other side, same thing, 9 minus 9, or 9 plus negative 9 is 0. So this is definitely a weird scenario because, heck, all my variables are gone. If you remember back to your two variable days, when this happens, when you are left with two numbers that are equal to each other, or a statement that is true, for instance, 0 equals 0, that would mean that you are dealing with what is known as an infinite solution type of scenario. So we're going to call this infinite solutions. Or all real numbers or all real solutions. So that might happen once in a while you're solving. So if all the variables cancel and you're left with two numbers that are equal to each other, in this case 0, then yes, this is an infinite solution scenario. On the flip side, let me show you another situation that might show up. Let's see what would happen if we were to, let's label these ones 1, 2, 3. And let's try to solve this. So same thing. Let's try to eliminate, I don't know, z's this time. So I'm going to pick, let's pick 2 and 3, and I'm going to multiply the bottom one by 4 to make the z's opposite, so negative 8 and then positive 8. So I'm going to take 3, I'm going to multiply it by 4. All right, so 4 times this is negative 4x. Plus 4y plus, what is that, 8z, and then 4 times negative 3 is negative 12, okay? Then I'm going to bring down equation number 2, because that's the one I'm pairing it with, and I'm going to write that, so 4x minus 4y minus 8z equals 2. So I'm going to add these together. Now, similar thing will happen. The x's will cancel, the y's will cancel, the z's will cancel. So you're left with just literally 0 on the left side because everything cancels itself out. On the other side, however, I'm going to get negative 12 plus 2. That's going to give me negative 10. Now, unlike the other one, this definitely does not equal this. So when that happens, this is, if you want to guess, not infinite solutions. This is going to be what's considered a no solution scenario, okay? So when you're doing these problems, if this does happen to you, all your variables cancel, you're either dealing with a no solution scenario where you're left with two numbers that are not equal to each other, or an infinite solution scenario where two numbers are equal to each other, okay? But in both scenarios, the common theme is all the variables just kind of eliminate themselves. So to get a better understanding of this, let's take a look at what we're actually doing when we are actually solving these, but we'll do it in a graphic sense. So let's take a look at that. So you're all very familiar with two variable or XY axis graphs, right? You've been seeing them for a very long time. And in fact, they're a very good way of visualizing, for instance, the solutions for system of equations, usually where those two things intersect. But what does it mean when we're doing it with three variables? So let me explain that a little bit. So yesterday when I was posting the answers to the odd problems, you'll notice that some of them looked like this 3, 1, 2. There was that additional z value. Well, let me show you what that actually means visually. Now, when I put these side by side, they look like, normal graph or normal points, right? You have 2 is the x, 1 is the y, right? So that's plotted in the right place, and 3 is x, 1 is y, so that's plotted in the right place. But in reality, we actually are dealing with more than just 2 variables here. We're actually dealing with a third, and that is the z. Well, the way this works visually is that z is actually 3-dimensional. That z is actually coming right at you. Let me show you what I mean. If I tilt this, you're going to see that this third dimension, the z-axis actually comes right out at you. So let me move this a little bit. And if I just look at it and tilt it fully, you'll notice that this a value doesn't have a z, so it's still in line with the x and y axis, but this b actually sticks out 2 away from that x and y axis, so it's actually coming out at you. It's just kind of hard to do that or see that visually. So what does this mean when we're doing not points, but when we're doing actual equations like we've been doing? Let me show you what that means. So when I show you one of the ones that we were doing a couple days ago from the form, one of the problems that had a solution, when I graph this, you'll notice that this actually is a line in relation to the x and y axis when you look at it. But when you look at it 3-dimensionally, this is more of not just a line, but it's more of like a sheet of paper. Now in math, we call this a plane. And when you put 3 of these equations together, so 3 pieces of paper together or 3 planes together, what you'll notice is that these all come together at a singular point. And I will try to show that for you. So that singular point is kind of right there, 3-dimensionally. So that point, or that x, y, and z, would make all 3 of those planes equal to each other at that moment, making, again, that system of equations true. Now, the problems that we were dealing with today, for instance, this one, these 3 equations, when you graph them, they actually end up graphing on top of each other. So it makes total sense that this has an infinite amount of solutions, because every single x, y, and z value they're right on top of each other. On the other hand, that other one that we were dealing with today, when you look for where is their solution, well, they don't all come together at one point. In fact, they do come together, but the problem is all 3 of these things never actually fully come together ever. So in this case, there is no solution or a point or an x, y, and z that makes any of these true at one spot. In this case, 2 of these planes are parallel to each other, and then one of them is slicing through it. So this is visually what's going on when you're solving these, and we're going to talk over the next few days a little bit more about the visuals of the 3-dimensional side of these problems, okay? So again, if you have any questions about the system of equation problems, you can always stop by office hours. We're more than willing to help. Today, you'll have a few more problems to try, at least in the algebraic sense, before we hop on over to the visual side of these things. So you guys have a wonderful day. Bye.